Hi everyone, this is Mrs. Donovan. Today we're going to take a look at the Unit 5 Day 6 notes. This is the last page of the notes. Now that we've taken a look at how to identify which congruence method to use to prove triangles are congruent, remember there are 5 of them. There's side, 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 angle, side, angle, 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 side, and hypotenuse leg, which also requires you to have a right angle. Now we are going to give you a taste of what a fully written out proof looks like. So what we want to do is begin by reading our givens and marking our model. So we know angle A is congruent to angle G, so I want to mark that in my model. I also know that segment CE bisects angle ACG, bisects this angle. So remember, when I talk about bisecting, when I ask myself, what does it mean to bisect, to cut in half, and what is being bisected? Angle ACG. So I want to mark 2 congruent angles formed by the bisector CE at angle ACG. Now I want to mark these differently than my first set of angles, so I know that I can distinguish between angle A and angle ACE and G and angle GCE. Now I want to try to come up with the method of congruence that's going to make triangle GEC congruent to angle or triangle AEC. Remember, there's no looks like method, there's no looks like theorem. So even though CE appears to look like it might be perpendicular or bisecting AG, that information is not given to me, so I cannot mark that as congruent. I can, however, mark CE congruent to CE because that is a side that is completely shared in these 2 triangles by that segment CE. So now what I like to do is I like to focus on just one of those triangles to try to decide on what method I'm going to use. So I like to highlight what I have. I have this side here, and I have this angle, and I have this angle. So I have 2 angles and a side. So I have to decide, so I know side, side, side is out because I don't know all 3 sides. Side, angle, side is out because I don't know 2 sides, I only know 1. I don't know I have a right triangle, so hypotenuse leg is out. So I have to decide between angle, side, angle, and angle, angle, side. Which method do you think that we will use? That's right, we're going to use the angle, angle, side method because only one of our angles touches that side. So we are going to use angle, angle, side. Now this is the way that I like to begin my proofs every time. I like to set up a plan, get a game plan in mind. So now that I have my game plan in mind, I'll walk through and actually formalize this proof for my reader. So remember, the first thing we do in our statement, reason, column proof is to provide the given information, and our reason is simply given. Now, I want to start to use the information from my given. So I see angle A is congruent to angle G. There's not anything else I need to do with that. I already have my congruent statement. So I like to put an A next to that for angle. I also know CE bisects angle ACG. So remember, that told me that these 2 angles were congruent because an angle bisector divides an angle into 2 congruent angles. So I see here if I have an angle bisector, then it divides an angle into 2 congruent angles is my reason. So this must be the statement that goes along with my marked congruent angle, angle ACE, congruent to angle GCE. And I like to put an A there so that I know I have a second angle. So now I have 2 angles. I know I'm proving this by angle, angle, side, so I have one more congruent statement, and it's going to be about sides. Remember, CE is a shared side between these 2 triangles we're trying to prove are congruent. So I'm simply going to write that CE is congruent to CE When a set of sides or angles are congruent to themselves, we use the reflexive property. So I'm going to put an S here for side. Now yes, the way this was written, I have an angle and then an angle and then a side. It doesn't matter the order that your statements are written in. What really matters is where the angles and sides are positioned in your model. And we had already decided that these two triangles are congruent by angle, side congruence. So now that we've done one together, I want to guide you through the second one, but I want you to do a little bit more with it. So the first thing we want to do in number 12 is read our givens and mark our model. So take a moment to do that. Once you mark your model, I want you to think about which method you think you're going to use to prove that triangle ADB is congruent to triangle CDB. Okay, so we know triangle ABC has a perpendicular bisector of BD. Remember, perpendicular lines form 90-degree angles. Bisectors cut something in half. In this case, it's a segment being cut in half. So I know that BD is meeting AC at a 90-degree angle, and I also know that BD is cutting AC into two congruent parts. Folks, I just realized I have a typo here. This should be an AC. Change that. You're given to AC. So we have AD is congruent to DC, and we have these right angles since BD is the perpendicular bisector. But I need three pieces of information to show that the two triangles are congruent. So again, I'm going to use that reflexive property. So now let's take a look at what method we think we're going to use. So this time we have two sides marked on a triangle, and we have that right angle. Again, I only focus on one of the two triangles when I'm trying to decide on my method. So looking at these two triangles again, I have two sides marked, one angle. And the angle is nestled between the two sides, so this is side angle, side congruence. So let's start to write this up. So we start with our given information, triangle ABC with perpendicular bisector BD, and that is given. So I always want to set up my problem with what I know. Now from that, in statement 2, we've said angle ADB, this angle here, and angle CDB, this angle right here, are congruent. Well, how did we know that? Well, let's look back to our given information. Is it that BD is perpendicular or a bisector that tells us that? That it's perpendicular. We know that perpendicular lines imply that right angles are formed, which implies that they are congruent angles. So that gives me my angle. Now that's the only congruent statement I have so far. I have my angles congruent statement. Now I need two congruent statements about sides. So I look back to my given because that was a perpendicular bisector. There were two things happening here. So we took care of the 90-degree angles. Now let's talk about the bisector. If BD is the bisector, we said AD was congruent to DC. AD is congruent to DC because it's a segment bisector. Remember, perpendicular bisector is two pieces of information for the price of one. It gives me a set of congruent sides, so I put an S in parentheses there. Now I need one more. Where did my other side come from in side angle side? BD congruent to BD. what do we use when we are saying that an angle or a side is congruent to itself? Which property is that? That's right, that's the reflexive property. Again, this is a congruence statement, so I'm going to put an S there. That tells me I have my 3 congruence statements, so I am ready to prove that the triangles are congruent by side, angle, side. So I am almost done here. And I want to make sure that I write my proof statement exactly as it's written above here. So triangle ADB is congruent to triangle CDB by side, angle, side congruence. See you next time.